LeetCode problem number 79, word search. So this problem gives us a m times n grid of characters and a string word. Our job is to return true if the word exists in the grid. Otherwise, we return false. So this grid here, let's say the word is ABBCCED. So it must start with A. So we have A, B, B, C, C, E, D, A, B, C, C, E, D. And when all six characters are found, when all six characters are found adjacent to each other, that means it's a valid word. So another thing to note is that once we have used this A and B, we cannot go back to the old character, right? So the same letter cell may not be used more than once. Okay, so my solution to this problem is to use depth first search. And the way depth first search works is by you start from an index, for example here, and then you look down, right, up, left to search for the next character B. And once you have found that, then you go repeat the same thing again, right, until eventually it will search all the way until the end. If we don't, we would need to backtrack and search for other routes if there are other routes, for example. So let me run you through the code. So here I have a global row and column. So this row and column will basically store the size of the x-axis and the y-axis, the length basically. And here I'm using a double for loop to iterate through each cell. And let's say the word I'm searching for is FCEE, for example, right? Okay. Or let's use another example, SFEE, right? Okay, pretty good example, if I do say so myself. So the first thing I do is I iterate through the row and the column. So for each row, I iterate through each column. That means we get to see every single cell. And in my depth first search, you can just for now you can ignore this first, because this basically means if the index, which is currently at 0, reaches the word size, that means we have reached the end of the word and we have found that the word exists in the grid. This is the, I guess you can see, limit checking, so that it does not go out of bounds, right? If the row is less than 0 or row is more than the maximum row on column, remember that we set it over here, or that the current cell we are looking at does not equal to the current character that we're looking for, right? Okay, so let's say we search for S. So this is not S, this is not S, not S, not S, and we have found S over here, right? So when we found S, we enter the first search function, the recursive function. These two we ignore first. So here I kept a copy of the current character, right? So current character now is S. And then over here, I set the current board we are at to a hash character. So what this means is I am marking this cell in the grid as a visited cell, right? This will prevent our backtracking method to basically go back and forth forever, right? Because if both are the characters that we keep looking for, and that this also helps with dealing with that. We cannot reuse the same cell, right? So that's what this is for. Here I increment the index because we are moving to the next character. Let me space it out a bit. So the next character will be F. So let's say I search for S over here, and I'm looking for F right now. So I look up, no F, I look right, here there's an F. So I go to the next cell over here, I recursion, I come inside the function again, and I basically do the same thing, right? So next character I'm looking for is D, so I search up, no, right, no, down, so I see D. Once I found D, do the same thing again. I cannot search for up anymore because F is a visited cell. I can go left, I can go down, I can go right. Since only right we have an E, so once we reach E, this would trigger and it will return true. When that returns true, since look at this block of code here, if either one returns true, that means we have found our word. So it will only return true if we have found our word. And if any of the axes from the previous node over here, we have received a true, or over here receive a true, over here receive a true, that means there is a path to the end of the word. So what this means is that we can just return the flag true, and once that returns, we can return 1. Now let's say if we are looking for S, A, B, C, for example. So again, we start from S, F, D, and since to our left, right, and down we cannot see a C anywhere, so what we do is we return false. Over here return false. This will return false, and then we continue on searching for the next S over here. Right. Once we have found the S, we repeat the same steps just to find the rest of the characters. But since in this case there is no F adjacent to our current S, so in this case this will return false as well. And when it returns false, we continue on searching through another S. Since we have reached the end of the grid, this double for loop will finish iterating and it will return 0, meaning that we have not found the word inside our grid. Okay, pretty straightforward and a pretty simple path searching algorithm using depth first search. Overall, this was a pretty fun exercise. Hopefully my explanation was sufficient. That's all I have to show. Thanks.